Hi, welcome everyone. So sorry for that little delay, but without further ado, please help me welcome PR. Take it over.
Hi, good afternoon, everyone. Welcome to PyData Global. My name is Piotr Stepinski. I lead data science and development teams at AnythingLLM, specializing in industrial IoT platforms for water management. The focus of my work and my goal today is to show you a practical, real-world demonstration of the agentic approach to knowledge management. We are all facing the same problem, knowledge fragmentation. We live in a world of files, and everything seems to be a file now. Disparate documents, meeting notes, research papers, Confluence pages. We have all the data, but the knowledge is trapped. Just to think about Tom, new engineer in my team, asking, where can I find all the definitive guide on RAG? And my answer would be, guess what? It's split across 5 docs, 2 slide decks, something on GitHub, Confluence page. So it seems like we have all the pieces, but no picture on the box. So why build this system locally? There are several critical reasons. Privacy, you have sensitive documents you cannot share across a public API. You want to keep this privacy for yourself. Second is cost. Processing high volumes of data quickly becomes uneconomical. And third is ownership. So you want to process your data without relying on third parties. If the internet goes down, you still need to process your data. So our goal would be to build a 100% local pipeline for knowledge synthesis. Let's jump into architecture of this solution. And yeah, so we require modular agentic design. That's why we use Crew AI to orchestrate specialized agents, preventing one weak input from sabotaging the entire system. And yeah, the brain. So those are eyes of our system. We want to OCR these handwritten notes, but there is also brain, which is LLM here. And let me quickly jump into another view, because I'm going to just introduce local inference. If somebody is not familiar with how to do those things, it's pretty simple. I'm running this presentation right now on my Mac M4 Metal, and what I'm doing here, let me stop sharing this. So this is my console, and so this is basically the comment that runs for you. It's Docker. So in your Docker, you may run AnythingLLM. This is how I'm going to present communication with local service that I run here. Sorry. Here, here you have. It's a proof that it's running in the backend. So what I did in order to have those pretty looking APIs logged, I run this command. And here we go. So if you just look into the documentation of MLC-AI, you can see what exact comments I used to basically to set up a Conda environment in which I have this tool called MLC-AI, and I can serve it directly as a Hugging Face model, as you can see here. It's quantized, so it's pretty fast. if you keep in mind that it's still local inference, and pretty powerful, at least for the purpose of this presentation. So and let me jump now into something called AnythingLLM that I just showed how I run it in Docker, and I'm going to prove that it's running, that it's up and running, this server, this local inference, and it's here. So I've set up for you this thing in a Docker. You can see it's on my local host. So I communicate from Docker, and it's pretty simple approach. If you have documents and you want to talk to your documents, basically, so you create workspace here and you add some files into your workspace, and you can basically chat with it, like the similar experience like you would have with one of the cloud LLMs, yeah, ChatGPT or Claude or whatever. So I don't know, that just to prove that it's defined here. It's system default LLM preference for this workspace. If you go deeper into setup of this thing, you may see, believe me, that it's local, and I asked him to summarize my note, and here's the point. Actually, this note was in PDF, so there was no chance for me to analyze this PDF, yeah, because it's not this model, this LLM is not capable to accept PDF as an input. It needs to accept clear text. So at the end, once I provided the clear text of my note, it was able to summarize this text, and that's fine. And now I'm going to jump back into my presentation, where I'm going to prove you how, with this agentic approach, I may actually achieve the thing that I wanted to have from the beginning. So I may have the whole chain of different tasks from OCR, our PDF, and then improving OCR with LLM, and then up to retrieving real knowledge from this the set of nodes that I have. So let me jump back into the presentation. We are here. So yeah, let's think about it. For the purpose of this presentation, I prepared 10 notes on different subjects. Some of them are related, some of them are technical. Maybe there is meeting node somewhere, all handwritten. I'm going to show you some example moving forward. And what I would like to do here, I would like to actually OCR those files, digitalize them, and find out what is related, and build a cluster probably of nodes that are related, but not only on keywords search. No, I don't want to only have traditional retrieval, but I want to have something more advanced. And first problem that you would face. So okay, if you look at the system design, there is agentic approach. We use Crew AI to orchestrate specialized agents, preventing one weak input from sabotaging the entire system. So the workflow is split. First, we have this vision specialist for the raw text, and then you have also librarian and senior editor, and those guys are going to clean, are going to deliver you context of the node, and also they're going to clear the raw output from OCR. So let's think about it as an eye and brain. That's also a good use case for LLMs, that this improvement of OCR. So let's jump into phase one. The phase one is called DI. It's pre-processing, and as I said, standard OCR would be is not that great with the very messy notes, messy handwritten text. So we need to use split pipeline. And I'm just to briefly introduce you an example from my code, because this is maybe the most interesting part of it. So it's yeah, we observed what I said, that sometimes OCR fails on thin pen strokes. So the key of the solution is I use OpenCV dilation operation to fatten the ink strokes, and transforming fragmented handwriting into a clear marker pen for the OCR model. And I use two versions of the image. The first version of the image, a sharp version, to find text boxes and preventing ghost boxes. Second, a thickened, high contrast version for reading the text, making find ballpoint pen look like a bold marker. And this guarantees high quality input for the LLMs. And I'm going to let me explain how LLMs is used in next phase. So with clean text, the LLMs apply contextual reasoning. So the librarian agent tags the domain, and the senior editor agent uses that context to correct technical jargon errors, ensuring clean JSON output and false byte identity. And the absolute is fuel for our graph that I'm going to show you at near to the end of this presentation. And now let's look at two seemingly disconnected files. So those are handwritten notes that I mentioned in the beginning of the presentation. The note number 10 and number 3, just for presentation sake. First is about use case of RAG and another LangChain setup. So documents used for building a RAG pipeline, note number 10, note number 3. Details on LangChain setup mentioning chain of retriever LLM ready to integrate with pipeline. So we want our system to retrieve connections between these automatically. And these nodes are connected in two ways. There is exact keyword match on pipeline. And secondly, there is semantic architecture match. So the concept of RAG system in node 10 is semantically equivalent to retriever plus LLM in node 3. So if we can find those connections and build this network based on those connections, we prove that the system in some way synthesizes knowledge, comparing to traditional RAG where you just retrieve documents based on your query. So let's jump into demo, how it works and how it is built. So change the window here. Okay, we are back into our console, and by the way, this whole presentation and code is published to GitHub, so it's you can just play with it if you want after the presentation, and you know, feel free to have some fun. And for now, I focus on part of this code, which is basically the place where we process our data, where we initialize our agentic workflow, basically. So okay, here we have tool definition. So it's pretty simple. So in order to run your Crew AI pipeline, you need to build your agents and give them tools, basically, and define tasks for them. That's the concept. There is some code prior to that, as you can see, but mostly those are helper functions for OCR and things like that. There is setup of this local LLM. Somewhere like here. But I want to jump directly into this crew AI, because this is maybe the most interesting part. So yeah, so we define basically our tools based on base class, base tool. We just inherit from them, and then there is also place where we initialize. Okay, this is process single node. So having the path to your PDF file, our crew is going to, okay, here we have, here we initialize the object of LLM. Even if you have OpenAI Quen here, it's this Quen that I'm serving in the backend, no problem. I can prove with showing that config it's here, it's all local. Yeah, that's the proof. And we go further. We have agents here. As I said, this first OCR agent is going to read your is going to provide you OCR raw output, which is already improved because we did this trick of two phases, as I explained before in my presentation. And then we have a librarian agent that, because we, as I said, after raw OCR, they're going to be very messy output, and you need to understand actually the context of this node. And once you understand it, you may use LLM to further improve your node, basically, this raw output. And so that's why we have librarian. We want to understand the class of this document to help our senior editor agent to basically reconstruct nodes. And I'm going to give you a funny example of how it actually works. There are that's how we with this trick we make use of LLM as a brain. And then we have another definition and a set of definitions of tasks like extraction, analyze raw text, and blah blah blah, things like that. At the end of this whole thing, we would like to produce JSON. We would like to force our LLM to give us a clean JSON in order to do something with it. In this case, for the sake of this presentation, what we're going to do, we're going to show clusters of relationships between our nodes, and we're going to visualize type of relation in our graph. So here we are, and I'm going to show you how it works. So it's going to take some time, prepare for that. Even for those 10 PDFs, it's going to be, I don't know, from minutes to dozens of minutes. So I wanted to make sure that nothing fails during presentation. So I'm going to show you only the output of this code in my console, and it's pretty good. So, and just to show you how it was able to actually improve OCR. Basically, this is the one interesting part. So, as I said, so we have this vision specialist. And what he did, this guy helped us to get the raw output from OCR model, which is kind of messy. I may show you, if I had more time, I probably may show you the true content of this node. We can see something, there is date here, there's Alice, Bob, whoever, vector DB options, Kirana, DBus, lineup, whatever, may guess that there is something different here. Yeah, actually, ChromoDB doesn't exist in text. So we need to ask a librarian to help us analyze raw text, and he's going to determine the domain. Yeah, as you can see here, and yeah, he answered that the domain is technology. And then, having domain and having this raw output, we ask senior editor to review the raw zero text, and we inject this huge prompt into this agent and wait for completion. And voila, and it's pretty decent, the output. Yeah, we can see that there is markdown even formatted output, and we can see that VectorDB options now are ChromaDB like, and he even shows us what he transforms into ChromaDB. What was the question mark? What was unknown from original raw OCR? So yeah, that's a huge success. We were able to basically to get something from this messy data. And then as the last step, we have another agent called librarian, whoever knows why, but he was able to extract main topic and keywords from each node, which is going to be used moving forward for our network X library to build the graph. So having that, we have JSON file. This whole output from all nodes is now it sits now in JSON file, and with this JSON file, we are building Enchain's knowledge graph. And there are different types of connections. I don't want to show all of them. The most interesting to me is this final visualization of this JSON file, because this actually is going to show you what is the final knowledge that you actually extracted. Yeah, it's interesting, kind of interesting. So for instance, for those nodes 3 and 10, we see that there is community that our code found, and let me see if we can actually understand example. Let me switch to another view. Which is here. And this graph is basically based on this JSON, which is output, which is the work of our whole crew AI team. This is the full graph, yeah. So I will search for node 3 now. Node 3 is blah, blah, blah. It's here, as you can see. What it shows different kind of relationships between those nodes. So there's similarity check between, and it says not that much, because for the similarity check, there is it's not that descriptive, if you know what I mean. There's something around 70, something 0.7 for each. So it's like who knows what is similar and what is not. So the more important one is this semantic similarity, semantic connection, and also shared keywords connection. So here we can see that node 3 and 10 are directly related based on keywords, but there are also there's also semantic relationship between them. So they form a group together. Yeah, basically. Here we can see only this connection, because for our library to build communities, basically the shared keyword connection is more important than semantic. So we can't actually understand. So it looks like there is only direct keyword in both nodes. But here it's even more obvious for node 2 and 5. If we click at them, that node 2 is here and 5. It's semantic relationship. So, and there is no on VectorDB, and there is nothing in node 2 about. So in node 2 is about VectorDB, but in node 5 there's no explicit keywords related to VectorDB that shows that somehow we were able to identify this semantic relationship between those nodes. And actually, it makes sense because this is about hybrid, related to hybrid search strategy, and this one is database service comparison. So yeah, note. So it's proving that the system finds non-obvious and high-value connections as well. Let me jump back into my presentation. How much time do we have? Oh, we are almost. That's interesting. Yeah, I need to wrap up. Well, okay, we are at this demo part. Okay. Okay, let's summarize this whole presentation. So we didn't just build a text extractor, yeah? We demonstrated that you don't have to compromise on quality to get privacy, yeah, because it was all local, and we were able to extract quality, interesting information from very messy data. By using a modular agentic architecture, we allowed smaller local models to punch above their weight class, basically, because it was, yeah, as I said, it's on my metal, it's on M4 macOS. We fixed errors and we found connections that would usually require massive cloud computing. So for sensitive private data, this proves that the local agentic pipeline is not just a backup plan, it's the responsible choice for knowledge management. And yeah, that's pretty it. If you have, I'm ready to take any questions, if any. And yeah, you can find me on. You can just grab this code through GitHub. You can connect with me on LinkedIn if you want. Stepinski at the end. So sorry, I didn't. Thank you very much. It was a pleasure to present. Yeah. Yeah, DeepSeek OCR. So with this DeepSeek models, I don't have much experience. There are not only DeepSeek; they have OCR. You have many different vision models that, in theory, you may run. But those are, from my experimentation, it was rather more expensive computationally, even locally is served. I don't know how DeepSeek OCR works in cloud. I have no experience. I assume it's fast, yeah. But I was testing locally Phi model for vision, and I couldn't get any quality results from it. So I said that for local inference, we have to do something simpler, basically. So smaller OCR models and small LLM to fix the output, basically. That's the concept. Of course, if you plus DeepSeek, I don't know if exists DeepSeek version quantized and small. In the past, I tried to run DeepSeek on super powerful machine in my lab, and it was super slow. There's a question about GitHub repo I've shared. I can share, so it's here. Just grab the QR code, or I can even click here and share this through. It's here. It's not that clean, to be honest. I tried to clean what. Okay, somebody already did that. How is your experience at the conference? Hope you are finding productive. Belong to the data community. Okay, that's the question. And Vim configuration libraries. Okay, that's great. Yeah, okay, we'll do that. No problem. Moving forward. I have dot files basically. I don't know if my dot files are public or not. Okay. Okay. Let me. After the conference, I'm going to make sure that there is something on my GitHub that contains lazy theme basically, my lazy theme configuration.
I Pedro. So I need to end the section now. Thank you so much for your time.
Take care.
Welcome to the next section.
Yeah.
All right, bye everyone. So see you in the next section.